Hi, welcome everyone. Welcome to CHEMBLAST SK025, and for today's session we're going to look into topic 6, which is benzene and its derivative. So we're going to focus on question number 2, which have 3 questions, which is question A, question B, and question C, consisting of 10 marks altogether. Let us first look into the first question, which is question 2A. So for question 2A, we need to state 2 criteria of aromaticity. So in order to answer this question, we're going to look into the component or the criteria that can satisfy for a compound to be aromatic. And the first thing that comes into our mind is the structure of benzene. As what you can look here, the structure of benzene is cyclic, and it have a carbon-carbon double bond, carbon-carbon single bond, carbon-carbon double bond, single bond, and double bond alternately. First thing first, we can say the benzene or the aromatic is cyclic, and second, it is planar because it lies on the same plane. Next, it is completely conjugated because it have carbon-carbon double bond, single bond, double bond, single bond, because electron can be delocalized in order to become stable. And next, it obey Haikals rule because in this case here it have 2, 4, 6 electron. So according to Haikals rule, we have 4n plus 2, which is 6 pi electron. So when we determine the value of n, which is 4n is equal to 4 pi electron, we have n equal to 1. When 1 is an integer, therefore it obeys Haikals rule. So we know that any of these two answers can be accepted. Okay, that's all for question 2A. For question 2B, the alkylation of benzene using 2-chloropropane in the presence of AlCl3 give compound W. Bromination of W in the presence of light yield X. So the tips here is to draw the structure of the 2-chloropropane first. As what you know that 2-chloropropane will have 3 carbon. 1 carbon, 2 carbon, and 3 carbon. And at carbon number 2, we have Cl, which is above here. And then, in order to do the reaction, we know that we have a benzene reacting with 2-chloropropane in the presence of AlCl3. So as a tip given here, we need to detach the halogen group, and the rest of it will be attaching to the benzene. So what we're going to have here is the benzene, and then we can attach the rest of it, which is shown here, and then you're gonna get this structure. So the next step is the compound W that has been formed will undergo bromination. So bromination, we have Br2 in CH2Cl2 under UV, and because of Br2 in CH2Cl2 UV, it will undergo the reaction of free radical substitution, and hence the product form must be the most stable, which is in order to form the X. So we have a benzene here, benzene ring, and then as what you can see, the Br can be substituted. The Br can be substituted on this side, or at the middle side here, and we need to substitute this at this side because it gives the most stable structure. So you can get Br to be here, which is the most stable. If you were to substitute Br or at the end of it, let's say you substitute Br at the end, which is something like this is going to give the minor product, which is less stable. So we have to pick the most stable structure, which is Br at the middle, at the center of the carbon and H here. Okay, so because of this reason, we can draw our W to be this structure. Okay, and meanwhile for X, we're gonna draw the structure to be Br at the middle because it gives the more major product, which is the most likely to occur. Alright, so for question 2B2, we need to write the mechanism for the formation of W. So as usual, when they ask for writing the mechanism, we need to give the step by step. And it happens when we react benzene with 2-chloropropane in order to produce W similar to the previous step. So as what you can see here, this is benzene And this is 2-chloropropane. Just now I draw it in the skeletal structure, but now I draw it in the condensed structure so that you can see it more clearly. And then you have the AlCl3, which is the catalyst. And as what you can see here, Cl gonna be removed, and then the balance of it, we're gonna attach it on the benzene part. Okay, and the byproduct that gonna be formed is HCl. So our W is basically this carbenzene here. Explanation, we need to do it step by step. So at step number 1, we need to form our electrophile first. So here is our electrophile, which is the haloalkane together with the AlCl3, our catalyst. And then from here, we can see that there is a lone pair. So the lone pair will attack the Lewis acid, and this will form the complex. And from this complex, you can see that there is a positive side charge here and negative charge here. And because of this reason, this bond will be broken and given to the more positive side. And once this happens, you can see that the C will be empty, and that is why it carries a positive charge here. And the 2 electrons will be given to Cl so that it is occupied, and then the Al will carry the negative charge. So here is step number 1. And as what you can see here, our electrophile has been produced, which is the positive charge here. And then we're going to proceed to step number 2, which is the formation of uranium ion. So just now, we have produced our electrophile from the first step, and benzene is our nucleophile. So the nucleophile must attack the electrophile. I repeat, the nucleophile must attack the electrophile. And the nucleophile must attack from the carbon-carbon double bond because it has the highest number of electron density. So the double bond, the electron will attack the positive charge here, which is electrophile. And because of this reason, there's going to be a formation of uranium ion. So as what you can see here, the alkyl group is attached at this point. Okay, and when it attached at this point, we can see that it carries a positive charge here. But the positive charge here is not permanent. It can be transferred because electron can be delocalized. So electron going to move there, and hence the positive charge will be transferred here. At the same time, the electron can be delocalized again and causing the positive charge to be there. So it happens continuously. So you can pick any structure for the step 3, which is our step 3 is deprotonation. So we're gonna pick any structure. Let's say I'm gonna pick my first structure here, which is I'm gonna copy back, and then I'm gonna react with my AlCl4 that I have produced in step number 1. So as what you can see, I have the lone pair from the Cl, so it have electron density. So the here will be broken down. This bond here gonna be broken down, and this lone pair will gonna attack the hydrogen to form HCl, as what you can see. And then the single bond here will become the double bond. So our product going to be a benzene, and then the alkyl group, which is CH3 which is, if you expand, will be given like this. H and Cl will be combining together, and AlCl3 is our Lewis acid, where we're gonna get back our catalyst by the end of the reaction. And as what you can see, from the first step and to the third step, we're gonna get into the product that we wanted, which is product W. Alright? And for the last question, which is question 2C, we need to state the reagent C in the reaction above. So here is the ethyl benzene. So from the ethyl benzene, it's gonna become nitro ethyl benzene, which is number 2 and number 1. And then you can see here the nitro will be attaching at ortho position. Okay, and because of this reason, we can undergo the process of nitration. So for the process of nitration, we're gonna use the reagent very specifically. So we need to write as concentrated HNO3, concentrated H2SO4 at a specific temperature, which is 40 to 55 degrees Celsius. The keyword concentrated here is compulsory. Alright, so I think that's all for today's session. See you again some other time. CHEMBLAST SK025. Bye!